Welcome back to the Blazor Server In-Depth course. In this lesson, we're going to be covering dependency injection. Specifically, the dependency injection that's baked right into .NET Core. So we're going to look at that. Now there is ways to use other dependency injection systems, but this is the default one that comes right out of the box, and so we'll use that and look at it and see how it works. So let's go over to Visual Studio and we'll create a new project. A Blazor app. We'll call this Blazor app, and this is going to be dependency injection demo. And hit create. We'll make sure we have the ASP.NET Core 3.1 selected, Blazor app selected, and HTTPS checked. Hit create. So let's look at what's coming right out of the box with Blazor. So we go to startup.cs. This is where our dependency injection is configured. Now, if you're not familiar with dependency injection, what happens is instead of us saying, when we instantiate a class, we can say equals new and then create that class right away. What we're going to do instead is ask dependency injection, which is a system that runs in the background or is kind of sitting in our application waiting for requests. We're going to ask it for an item. And it's going to go into its memory, it's going to pull it out and give it to us instead of us saying equals new. And that allows us to create a loosely coupled system where we can remove those dependencies and unit test each part of our application without having to have all these dependencies and interdependencies hooked up. So that's a really short explanation of dependency injection. I do have a video on it, as well as a video on the dependency inversion principle, part of the solid set of principles, that both of those are on YouTube. Are two from Razor pages. So let's go ahead and bring those in. And so what that'll do is, if there are any Razor pages in our app over here, then it will add those to dependency injection. And then it also says add server-side Blazor. So any Blazor items get added to dependency injection as well. That means when you request this fetch data, it's actually getting the instance of this code from the dependency injection system, and it's allowing for us to inject other services. We'll get to that in just a minute. So there's Razor pages and server-side Blazor, and then finally there's one more, and this is a demo one. Remember, we have the fetch data page, which is really the weather page, the weather forecast, and it gives us some information. That has a data backing called weather forecast service. And what it does is it creates some random information. So there's a random next, here's the temperature, and then the summary is a random value from this list. So even the temperature and the summary don't match up, and that's fine. It's just grabbing random information. But this right here, this weather forecast service, this is a class over the for each. All right, so I'm going to explain this in a little more detail, and we're going to do this manually because sometimes it's a little confusing to kind of see all the pieces and not really understand how they fit together. So let's do this. On the index page, right now, it just says, welcome to your new app, and it says hello world up here. What we're going to do is we're going to add a section that says your random number is, and have a value, which we don't have yet. Now, I'm going to create a super simple data access class that gives us back a value. So I go over to data, the data folder, I right click and say add, we're going to add a class. And let's call this class dummy data access. And we're going to have a public int get random, or no, get user age. Again, this is just sample code. All right. And what I'm going to do is I'm going to create a private int age variable, and I create a constructor. In the constructor, I'm going to say random rnd equals new random, and then age equals rnd dot get, it's next, and we're going to say random age between 1 and 120, just to have a number. And what we'll do is we will return age. So what this little sample class is doing is the user is going to call this getUserAge method, and it's going to return back an integer every time. Now, when the class gets created, when the class gets instantiated, it's then called a constructor. The constructor creates a new random number generator, and that generates a new random number between 1 and 120, and it puts that value into the age variable, that private int age. And the getUserAge, when you call it, just returns the age variable, which means that when you first instantiate this, it will get a random number, put in age. But if you use the same instance over again, you'll get the same age back. If you use a different instance, you'll get a different age because of this random number. All right? And this is important to do because I want to show you what the different types of dependency injection values are. Use scoped, use singleton, and use transient. So we'll see all three of those and how they react differently with this class. Right now, the thing to note is every time you instantiate this class, you'll get a new age. But if you use the same instance, you'll get the same age. Okay, that's the big deal with this class. Now, I'm also going to create an interface for this. So control dot extract interface. I'm going to call this iDataAccess. And the reason why is to simulate the idea that maybe you have more than one data access, and you could call, or you could create a class off that interface for SQL and for SQLite, and in this case for dummy data. And now it's in a new interface called iDataAccess. Okay, so there's our class. So we have something we want to inject into this index page. We want to bring in the dummy data access instance into this page and then get that random number. So the first step here is that we need to put it into dependency injection. Let's go to startup, which is down here. We're going to add a new service. So services dot add. We have actually three options here. It's not showing a third one yet, but these are the three that IntelliCode is offering for us and saying these are the ones you probably want to use. Add singleton or add scoped. And then down below, we'll also see there's an add transient. And that's right down here. So those are three options. We're going to look at these each in turn. So let's start with add singleton. We're going to say I data access, I data access. It's saying I dummy data access for some reason. Let's find out why. That's interesting. It created in the I data access file, but it created I dummy data access. And that's not right. That was, I believe, is a glitch in Visual Studio. So I data access and data access. Oops, dummy data access. Okay, so what am I doing here? Well, I'm adding dummy data access as in the dependency injection system. And my first pushback on that is, well, how does your system know which one to ask for or which one to get? You see, if I'm asking for, let's just look at the fetch data access. Well, we don't have it up yet. We'll wait. But if I'm asking for an iData access, why would I be expecting two different ones? Or how would I know to ask for a specific iData access? That's where you're getting into the realm where you probably should have an iSQL data access then and an iDummy data access. That way you can have both in there and you can request the one that you want. Now, there is a possibility of getting multiple back. You can ask for a list of iData access and get every different type that's in the system. That is possible, but typically that's not what we do. I would encourage you, if you think you have to go beyond this model we're using right now, that maybe you rethink what you're doing and ask the question, is this really what I want? And is this really what my system needs? Because usually what happens is people just need to rethink their design a little bit to be a little bit more streamlined or a little bit more working with object-oriented programming instead of trying to fight against it. Okay? But if you really, really do need to have some of those advanced features, then you'll need to upgrade from this basic dependency injection system to a more full-featured one like AutoFac. And you can replace the dependency injection system in .NET Core and add in a new one, and it just takes over. So that is definitely possible. It's not something I'm going to cover in this course because it's kind of outside the scope of what this course is about. This course is about going deep into what Blazor provides us. But just note that is possible. The good thing is that all the tutorials out there for anything ASP.NET Core will apply. Whether it's MVC, Blazor, Razor Pages, they all apply because it's all the same stuff. As you saw up here, this is adding Razor Pages, or potentially adding Razor Pages. So even though it's a server-side Blazor, it's also doing Razor. We could also add MVC in here. So this code right here doesn't really change whether it's Blazor or MVC or Razor Pages. All right. So if you request an iData access, you're going to get back an instance of dummy data access. The other piece of important information we're going to look at is this add singleton. Right now, a singleton, in this case, what it's saying is we're going to create one instance for the entire life of the application. And everybody is going to use that same version. Now, that is not ideal. We don't want to do that typically because that means we can share data between user calls. And that probably isn't a wise idea. It's definitely not a good idea if you're writing data to that singleton. If you're just reading from it, maybe it's okay. But in general, you don't want to do this if you're writing data as well. Okay, so we're going to run this first and see how it works, and then we'll change it to those other two types and see what the differences are. So we're going to save this, and I have to run it somewhere. So let's go to index where we're going to need it, and we're going to say, I want to have first a using statement. So at using. This is for blazerapp.data. Because I want to access the data folder. And notice on the weather forecast service, there's, not the weather forecast service, on the fetch data.razor. There's an example for us right here. And that's why they do these different pages. So you can see minuscule or minor examples of each of these things so you know kind of how it all works. In this case, it's at inject. So since a Razor page does not have a constructor per se, or not exactly a constructor, we can say at inject, and it's like we're passing it in through the constructor. So we're going to ask for an iData access, and we'll call this DB. We can give it whatever name you want it to be. And then down here, actually, right here we can say at DB dot, and it was get user age. Okay? It's going to say your random number is, and then get that user age and print it right there. That's all there is to it. Okay? We ask for an instance of iData access, which will be a dummy data access instance, since that's what dependency injection has. And then we say db.getUserAge, make that call, and it's going to get the data back and display it right in this section. Let's run this. Wait for it to launch. I'm still using IIS, and that's okay. It's not the end of the world. So we have hello world. Welcome to your new app. Your random number is 16. Let's refresh the page. Nothing happens. It still says 16. Go to counter. Go back to home. It still says 16. Let's take this URL and let's open up Microsoft Edge. This is the older version of Edge. The newer version has Chromium. I haven't installed that yet, but it's a great product. So I go there. So a totally different browser, different type of browser, everything. Your random number is 16. Okay? So everyone's sharing the same number. Again, not ideal typically. Let's close out of this and stop this. And let's make one change. And that is, instead of add singleton, we're going to add scoped. Now, remember I said singleton is one instance for everything. Everybody gets that same instance. With add scoped, it's a little different. It's like a singleton, but only per user or per session is more accurate. And so what happens is that when you create an instance of the web server, you connect to it, it's going to create an instance of the dummy data access class. And then it will give you that instance every time you ask for it in that same session. Now, if you open a new session up, like a new page somewhere, then it will give you a new instance. So people don't share the instance across between one person to the other, but inside that one person session, they will have the same data. Let's look at what this looks like. All right, so here's our page. Our number is 56. Hit refresh, it's now 65. Hit refresh, it's 39. But watch what happens if I go to counter and go home. It's still 39. Now you may say, well, yeah, it's just saving the page information. Go back to counter and click a few times. It's 5 right now, right? Go to home, it's still 39. Go to counter, it's back to 0. Because every time you go to a page, it's reloading that page. So it is going back and calling this again, but because I'm in the same session, it's remembering the same number. Now, we go over here and reload this page. There we go. Number is 32. I refresh again, it's 55. But again, I go off, come back, it's still 55. But that's different than 39. I go off and come back, it's still 39. So these two right here are different sessions, and so they have different numbers. But yet inside that session, it still remembers the same number because it's using the same instance. That is add scoped. Let's change it one more time. Add transient. And a transient is every time you call this, get a new instance. Every single time. Doesn't matter if you're in the same session or not. Let's run this one again. And it's 28. If we refresh, it's 4 and 55. Let's go to counter. So it's 55 right now. Go to counter, go back, it's 26. Go to fetch data and back, it's now 50. It's 113. It's 95. So it's different every single time. If I come back over here, I reload this page, it's 77. Notice it's going to change again and again and again every time I go off. So that's add transient. It's different every single time. So I get asked the question a lot, well, which one is best? And there isn't really a best one. It's not about one good and two bad or something like that. There's a reason why we have all three of these as options. Opening a session and making multiple calls, maybe you want an add scoped, because then that session would live between calls in different pages. That is still dangerous though, because of the fact that you need to make sure you have your dispose done correctly on your class. Otherwise, you might leave a session open, and that wouldn't be good. So in general, I say if you're going to do sessions, then I want you to open and close a session in the same class. Don't try and do it cross classes. In general, I find that I default to add transient. That's the safest way of doing things because it ensures that I won't share data across different areas that I'm not expecting to. That's kind of my default. However, there are times when it makes performance sense to go to add scoped, because now it runs a little better. You don't have to reinstantiate something expensive that can be shared. And so that might make sense. There are a very few cases, where add singleton might be a good choice. This one right here isn't a great choice. There's no real purpose for having this as a singleton. Well, let me adjust it just a little bit. There's very little purpose. The purpose probably is that we can instantiate it once because there's no data saving here. It just news everything up every time. So therefore, who cares if we're sharing that instance across classes or across people and sessions? So I get that, but that's typically not what you'll be doing. So I would tend to avoid that unless you're being very careful. So be very careful to add singleton if you have any stored data. That's a problem because we say range from 1 to 5. What if that last number was whatever came out of our random number generator? So let's do that. Let's inject that into this class. So I'm going to create a constructor. And I'm going to ask for that class. So iDataAccessDB. And then we'll create actually, no. Let's store that. So control dot here and create initialize the field. So now you have a private read-only iDataAccess called _DB. Now down here, we could say _DB dot get user age, which, yes, that's going to be from 1 to 120. Let's back that off just a little bit so don't make our thing go crazy. Let's go with 1 to 10. How about that? So now, all I did was ask for it in a constructor and then save that variable in a private read-only variable that I can now access in my methods. Let's run this and see what it looks like in our forecast. This will determine how many rows in our forecast we get. In this case, 1 row. 1 row. All right, so we're only getting 1 row right now, which is interesting because we should get more than that. Let's find out why that's not working the way we expect it to. So let's put a breakpoint in. So let's split out and say the int upper value equals, and we'll pull this out right here. Upper value, like so. That way we can actually put a breakpoint and capture what upper value is. So we're going to run this. And now we go to fetch data. And it says upper value is, let's go to locals here, is 4. So we hit continue. And there's 4. We hit refresh, hit continue. And it doesn't come up on the screen. That's excellent. Let's find it. There's 4. Oh, it's still paused. That's why. There we go. We hit go off the page and go back on. It's going to hit again, but it's still saying 4. Ah, and I know why. So what we've done is over here on startup, we've got add transient for dummy data access, but its weather forecast is add singleton. I believe we should match that up because of the fact that this is asking for one of these. And so even though it's add transient, it's only going to create the weather forecast service instance once. Let's verify that. Let's run this. Go to fetch data. It's going to get upper value of 8. Hit continue. There's 8. Go off and come back on. The upper value is now 6. Let's take the breakpoint off. There's 6. Go off and back on. There's more. There's less. There's even less. If we hit refresh, it's going to change the list size each time. So now we have a truly random number for our weather forecast number of rows. All right. So what this is doing is it's getting the instance from our dependency injection in a class in C#. So this is how you ask for a class or a value from dependency injection in a class. So in a constructor, you say, give me whatever you want from dependency injection. If you're on a Razor page, then you say inject and give it the type and the new name to give it, or the variable name. If you want to inject multiple things, you could do that just by having another inject statement. Now, I chose to split this apart. So let's go to startup.cs. I chose to split it apart with an interface and an implementation, whereas weather forecast service did not. It has it just as the actual type. You can do either. The nice thing about using the interface, even if there's only one implementation, is that really there's two. So right now, well, if I had said pass in here the dummy data access, I'd have to pass in a dummy data access class. But since it asks for an iData access, I can pass in one that returns the same known value every time you call getUserAge. That way I can verify that if you pass in a 2 for this value, you'll get back 2 results in an array. And if you pass in a 5, you'll get 5 results from the array. So that's how you can use data. You can use unit testing to mock out these dependencies, remove the dependencies, and then test just the unit of work, just this, without the dependencies like this right here. But that makes it's a whole lot easier if you use interfaces instead of the actual strong type like weather forecast service. So that's why you'll see in my code, almost always I'll use an interface and the implementation. It makes it much, much easier for unit testing. And that's your second implementation. The first one is the actual class. So dummy data access class implements iData access. The second one to implement iData access is whatever dummy version you use when you're unit testing to remove that dependency. So that's it for this lesson. What we covered is the dependency injection system, which is all configured through this configure services method. We covered how to add a new dependency to the dependency injection system, what the different add types, whether it's add transient or add scoped or add singleton, what they all are and how they work. We covered how to then get the value out of dependency injection system on a Razor page, just that inject, or from a C# class, which is where you use a constructor and request that type through the constructor's parameters. So either way, you can use your dependency injection system to really make it easier and more flexible to use your different dependencies. Because we're declaring them all in one spot like this, they're very easy to swap out later. And this is one thing that people ask about a lot is, well, I have a ton of dependencies. This list is going to be huge. That's okay, because that just is a reflection of what reality actually is. Sometimes we hide that reality by putting, weather forecast, test equals new weather forecast. We put that throughout our code. to do that even in unit testing. So therefore, we don't create an interface for our models. So we do new them up, and you're going to have to for that purpose. They're going to get newed up. It's not really a dependency because there is no logic in this in this class. So that's how dependency injection works in Blazor Server. I encourage you to practice that. Practice scoped and transient and singleton. Almost forgot that. So practice those three and just try it out. Make sure you understand how dependency injection system works. Make sure you understand how to inject dependencies into a C# class and also into a Razor page, because you'll need to do both of those when you start working with Blazor for the first time. Okay? So once you've done that practice, come on back for the next lesson.